Hello everyone and welcome back to Just Finish Coding. I'm Sriram and this video is part 5 of our color switch series which we're making on Scratch 3. In case you've not watched parts 1 to 4, I will leave a card for you right here. By the end of this video, you'll have a completed scoring system and integrated mechanism that would pretty much generate levels infinitely, and also the rest of the game's backbone. We can begin by going into the obstacle sprite, and here what I'll do is rectify an error which I actually made in part 3. So what you can do is scroll down below to the big plus function, and here I forgot to set up the alignment. So what we can do is for both the r's, we can make sure that x is set to 55 and negative 55. Alright, now we can scroll up and create a new function. I'm going to call this generate level text. Remember that when the clones are being created, they're basically drawing in inputs from the level variable. In order to make sure that the clones can do this, the level variable needs to be updated at all times. In case the level variable just does not have enough digits to feed on the clones, then the game is basically going to crash. So what we need to do is update the level variable at all times, and this is exactly what this function will be doing. You can create a new variable called counter, and this is what we'll be using to add in elements on top of the existing level. These numbers are obviously going to be the number values of whatever obstacle we want to add on. The reason I'm doing this is because it gives me amazing flexibility over what objects I can create. And by that I mean under what conditions and with what probabilities. So what I'll be doing is creating the obstacles in the following way. I'll give a 33% chance for it to be one of the double obstacles and a 66% chance for it to be one of the single obstacles. Now within the 66% chance, I'll be having a 60% chance of it being one of the small obstacles and a 40% chance of being one of the large obstacles. This should be pretty easy to put into practice. We can start by setting counter to be a random value from 1 to 3. In case counter is 1, which is going to be true 33% of the time, then what we can do is set it to be a random value between 17 and 22. Remember that these are the number values for any one of the double obstacles. In case this is not true, which is going to be the case 66% of the time, then we can set counter once again to be a random value from 1 to 5, and in this case we can check if counter is greater than 3, which is going to be true 40% of the time. In case this is true, then all we have to do is set counter to be a random value from 14 to 16. These are going to be the number values for the big obstacles. Finally, in case none of these things are the case, then we can move on to the final 60% probability, and in this case we can set it to be somewhere between 11 and 13, which is going to be one of the small obstacles. We've done all the hard work now, and we can simply set the level variable to be the joint value of whatever the level was earlier along with what the counter value is right now. Things are going to be simpler for the level rotation. We can use the C1 variable to deal with this. So set C1 to be a random value from 1 to 2. Now we do have to be a little bit careful here, because remember when we're setting the level rotation, we were very careful to add in a bunch of zeros, whether it was before the 1 or whether it was before the 2. So we can simply join 0 to be whatever the random value of this is. And once we're done with that, we can simply merge that with whatever the level rotation variable was earlier along with what C1 is. We can repeat this process 16 times, fix our previous errors, and that's all we need to do for this function. Given that I've started to set variables in my stage, what I'll do is make that more consistent. So head over to the ball sprite and take out the part of the code which says set scroll wide to 0, and you can go up into the stage, and when we receive init, you can do it right there. We can also set up some other variables, most of which we'll be using right away. Let's start off with the first variable. I'm going to call this player died, and I'm going to follow this up with a question mark to indicate that it's a Boolean variable, and I will set it to be no. Next, you can set up a variable called score, which I will set to be 0. Then you can create number of obstacles, once again, which you can set to 0. And finally, you can create another variable called current player color and set this to a random from 1 to 4. What these variables do should be pretty self-explanatory by their names. The player died is going to be storing whether the player has already crashed into an obstacle or not. The score is, well, obviously going to be storing the score of the game. The number of obstacles is going to be storing the number of obstacle clones. And finally, the current player color is going to be storing which costume of the player is currently on. Given that we have 4 different costumes with 4 different colors, it is set to a random value from 1 to 4. You can now switch back into the obstacle sprite, and here you can go into the create clones function and make a few changes here. So what we'll do is change the number of obstacles by 1 every time before we create a clone, and you can also create a new variable called delete stamp. This variable is going to be very crucial when it comes to knowing which clones we have to delete and which clones we have to keep. We'll be using this significantly in the next video, but it's important to have it in place right away. You can simply set delete stamp to be whatever the number of obstacles is at the moment we are creating the clone. It's time to start using the function which we just created. Go ahead to when I receive tick, and here you need to make a small change. Remember that the sprite itself is not going to be engaged in the game. Only the clones of the sprite are, and this is why we had an if clone is equal to yes. Now we can make the sprite itself do certain things which the clones would not want to do, and this is why we change it from an if then to an if else. After this, create a new variable called level obstacles. This is going to differ from the number of obstacles, because while number of obstacles takes into account the number of clones which have already been created, the level obstacles refers to the clones that could be created based on the current size of the level. Given that each clone is created by 2 digits from the level, it is only reasonable to set the level obstacles to be whatever the length of the level is divided by 2. If the score is equal to the number of obstacles, it means that the player basically has no more clones above it. So what we need to do is make sure that as the score approaches the number of obstacles, let's say that the score is equal to whatever the number of obstacles is -2, then we basically need to create our clones. However, this itself requires a prerequisite. Before we create the clones, we need to make sure that the clones can actually be created based on the level. Basically, we need to check if the level obstacles are considerably more than the number of obstacles. If the level obstacles minus the number of obstacles is greater than or equal to 16, then we can make sure we add in the new text for the level, but otherwise all we have to do is just create the clones. This part of our code will work as long as our score is set up properly. However, we still haven't done this, so let's do it right now. As soon as the ball passes the center of one of the obstacles, I will be changing the score by 1. In case it's one of the double obstacles, then we can basically change the score by half for each obstacles, and this will give us the same result as 1. So let's actually implement this. In case the private y variable of the ball is greater than the y position of the obstacle, then what we can do is check if the obstacle is a double or not. In case it is a double, we can change the score by 0.5, and in case it is not a double, we can change the score by 1. If we leave the code like this, then the game is going to get pretty disastrous. The score is going to keep on increasing because once the ball even gets above one of the obstacles, the score is going to keep increasing by 1. In order to make sure that this doesn't happen, we basically need to switch off the score increment once the score has already been incremented. To do this, we can use our score increased variable. We can simply set score increased to be yes after we've increased the score, and we can put all of this code within an if score increased is no. This should fix all your bugs, and that is all we need to do for this video. We can simply test out our code, and if you followed this video and you've done everything correctly, it should be working pretty nice. If you've enjoyed this video, please make sure you leave a like, and also don't forget to subscribe and turn on the notification bell. Thank you so much for watching, and I'll see you in the next video.